Oh, look, Who Wants to Be a Millionaire is playing.
This is for 16,000. Which of these square numbers also happens to be the sum of two smaller square numbers? 16, 25, 36, 49.
That scared look on his face probably means he should have paid attention when his math teacher talked about square roots and perfect squares. Just in case this is ever you sitting in the Who Wants to Be a Millionaire chair, let's start learning. Here are some notes on square roots and perfect squares. The most important thing to know about perfect squares is that they are the square of whole numbers, meaning you should get no fractions and no decimals. It literally means the area of a square, such as in this picture, 3 times 3 equals 9. When they say to take the square root of a perfect square, you will get the dimensions of one side of the largest square. But once again, the most important thing to know about perfect squares is that they are squares of whole numbers. No fractions, no decimals. What is 3 squared? Here's a pictorial representation of what 3 squared would look like. Notice that you have 3 rows and 3 columns. So when you fill it in on the grid, you have to make a complete square. And when you do that, you notice that there are 9 squares completely made, showing that 3 times 3 is 9. So 3 squared is 9. Here is a pictorial representation of perfect squares and perfect square roots. Notice the 2 squared that equals 4. What that means is that 2 times 2 is 4, meaning that you have 1, 2 rows and 1, 2 columns, and that put together makes 4 squared. When you take the square root of 4, that means you're working backwards to find the length of one side, which would be 2. So 3 squared, meaning you have 1, 2, 3, and 1, 2, 3. And 3 rows and 3 columns makes 9 squares total. To work that one backwards, you would take the square root of 9, which would be 3. Take a moment to look at the 4 square and 5 square model. Here's another way to think about the numbers being squared by using your multiplication table. If you look, if there's 1 row and 1 column, it's 1 times 1, which is 1. Here would be 2 rows and 2 columns, so 2 times 2 is 4. Likewise, 3 rows, 3 columns, 3 times 3 is 9. 4 rows, 4 columns, 4 times 4 is 16. 5 rows, 5 columns, 5 times 5 is 25, and so forth. Here you see the square root of 9. 3 rows, 3 columns, so 3 times 3 makes 9 total. Here you see the square root of 4, and you can use your own centimeter grid to do these with centimeter cubes. Put 4 rows and 4 columns and fill it in, and you get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the square root of 16 is 4. Here you see the square root of 5. 5 rows and 5 columns. This model can also be shown as saying, what would the square root of 25 be? Meaning that the answer is 25, but they're asking you, when they say square root, to go back and find how many are in each row or in each column. So on this question, if I asked, what is the square root of 36? What is the square root of 36? You can see that there are 36 cubes total, and that there are 1, 2, 3, 4, 5, 6 rows, and 1, 2, 3, 4, 5, 6 columns. So the answer would be 6 squared. That 6 times 6 is what gives you 36. So here's an example of how the question can be asked in math. It says the model below can be used to find the square root of what number? So let's read this part. It says each side of the square is blank units long. Well, let's count. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. So each side of the square is 8 units long. There are blank unit squares in the large square. So if you were to count all of these up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, and so forth, you would get 64. You can use this information to write the equation 8 times 8 is 64. This model could be used to find the square root of 64. Let's look at another example. If the area of the below model is 49 square units, which of the below expressions can be used to determine the side length of this model in units? Well, I took out the multiple choice answers so you can't see the expressions below. But we can talk about how to create our own. So if the model is 49 squares total, how many square units are each side of the larger square? We can count. And there's 1, 2, 3, 4, 5, 6, 7. So it would be 7 times 7 is 49. So which expression can we use? We could either pick 7 times 7 or 7 squared. So here's a look at some examples. Find each square root. Remember that you're looking for a number that when squared will equal these numbers. So in the example number 9, the square root of 25. What number times itself equals 25? 5. Perfect. So the answer to number 9 would be 5 times 5 or 5 squared. By the way, if a math teacher were to make clocks, this is what it would look like. Be made out of perfect square roots. Can you look at the clock and tell me what time it is?